So as we try to slug through in identifying all hazards in a large and complex system, the system mishap models can be very beneficial to us. We've been saying over and over that it's easy to get lost in the system, to miss hazards, which can be bad, and to duplicate effort, which is also equally bad, because then the system analysis gets cumbersome. System mishap models can help us visualize the system and resulting hazard paths. Once we identify top-level mishaps, that can lead us to identify top-level hazards, and that can lead us to help us identify resulting risk, hazards, and hazard causal pathways, all things that would lead or that could lead to that top-level mishap. This here is a simple abbreviated mishap tree model showing only one top-level mishap for an aircraft uncontrolled fire. That's the top-level mishap in reality, and in future examples there will be several top-level mishaps within a system. But under the top-level mishap are also our top-level hazards. These top-level hazards help us categorize the fault path from the top-level mishap down through the system to better visualize hazard causal pathways. You can see how that's already setting us up to start to get pathways from that top-level mishap on down through the system. That also equates to our earlier hazard causal factor model. We see that the principles align with the system mishap model. At the top are the top-level mishap and top-level hazards, and we can work back or downward through the system to show that those hazard causal pathways, possible pathways, things that lower in the system could impact the system and cause a top-level mishap. In this, we have a mishap tree more accurately indicating several top-level mishaps with resulting risk below. Notice how much easier it is to visualize the top-level mishap with higher risk here, number 5, in contrast to the top-level mishap with lower risk here in number 1. We're already using the system mishap model to be able to better visualize our system. So let's bring this theory to real life. Here's a mishap tree for an aircraft accident. There would be more top-level mishaps, but here are several. I put them here for us to see. Top-level mishaps right here that would lead to an aircraft accident. Under each top-level mishap, we would identify risk. Risk, probability, and severity, just like we did in the previous slide. Then we would identify top-level hazards. Top-level hazards that would contribute to the top-level mishap. There would probably be several top-level hazards for each top-level mishap. And then you can identify other hazards that would lead to the top-level hazard. So you can see how pathways begin to emerge as we develop the system mishap model. Your text gives you an example of a mind map model as well. It would look something like this. So there are many advantages of creating a system mishap model. When we know the system vulnerabilities, where failures can occur, system mishap models help us more easily identify hazards that might cause that. The system mishap model also helps us visualize the hazards and hazard pathways. The models help us categorize hazards in a more systematic and logical way as they relate to system design. And also, because of the model's visual depiction of system hazards that lead to mishaps, it can be a great tool. The model can be a great tool to develop a safety case for the system. So from here, starting in the next PowerPoint and throughout the remainder of Unit 2, we are going to start getting into specific hazard analysis techniques. As we move into the specific techniques, we will be applying all of this foundational knowledge that we have learned about hazards. And as we go into the lessons on hazard analysis techniques. So we're going to take these foundational principles and we'll start applying them as we start to learn the techniques.